Alright, let's go through the question 9b of the question. So we are asked to find what is the volume of the solid revolution formed when I want to rotate region S 360 degree about the x-axis, leaving your answer in 2 dp. So definitely we can use your GC. Then of course, if you want to integrate you want to find the volume revolution that you want to rotate 360 degree about the x-axis, right? You must use this formula. So pi integral y square dx. But if you look at the formula given, right, or the equation given is x. So I need to manipulate a bit. So let's do the manipulation. X is equal to 6 minus y. Okay, so let's write down. So x 6 minus y minus 2 bracket square. Okay, so then I make the y the subject. So maybe I move this whole thing to the left hand side. So this will leave you to y minus 2 bracket square, right, is equivalent to 6 minus x. Then of course I want the y square. I don't want the y minus 2 bracket square. So I do the square root. So it's y minus 2 equal to square root of plus minus 6 minus x. Because when you do the square root, you must have a plus minus. Then this will be y is equivalent to 2 plus minus root of 6 minus x. So notice that there's two equations. So one is plus, one is minus. Okay, so let's go back to the graph, right? So you can see there's a yellow region here and there's a blue region here. So I must choose the yellow region to be y equal to positive. So y is equal to 2 plus root of 6 minus x. Then the blue region, right, will be minus. So y is equal to 2 minus root of 6 minus x. Then of course, so that's the first part to it. Then with this, right, I go back to the picture. So if you look at the picture right here, so from here all the way to here, let's just say I'm looking at the positive part. So this is y is equal to 2 plus, okay, 2 plus square root of 6 minus x. I want to find the so-called volume of revolution if I want to rotate, right? So the volume revolution will look somewhat like this. So this is the volume revolution. Then of course you do the revolution, it will be something like this. Something to be as such. Use maybe black here. So this will be the volume revolution. So meaning you just need to do the GC later. So you integrate from negative 3. So you can see that's why you calculated here's negative 3 all the way to positive 6. So this one you just put the first part of the volume will be pi of integral negative 3 to 6. Then you just need to sub in. So you can see, this is 2 plus root 6 minus x. So you just put 2 plus square root 6 minus x, then put a square bracket, then square, then of course dx. So this will give you something to be as such. So this is about 466.5265102. So that is the very first big volume. So you can see that the big volume encompasses all this part. So you can see that. Okay, wait. Yep. So this will be the so-called 466.526, so and so forth. Then definitely because we want the whole of this volume. So I want to minus off. There's two things that I want to minus off. Okay, let's look at the first thing that I want to minus off is actually this part. So you can see that this part, I want to minus off this region. Because when you do the revolution about this blue region, right, it's actually like that. Something like that. Yep. So meaning that you want to do the integration, pi integral of y squared. Then the equation of this, this part, right, will be y is equal to 2 of negative 6 minus x. So you want to integrate from 2 all the way to 6. That's what you annotated here, 2 and 6 here. So this part you just write down the second part. So you just put all pi integral 2 to 6. Then you just put in the GC, right? So this will be 2 minus root 6 minus x, then, 6 minus x, right, square dx. Then this will give you about 8.3775. 79475. So this is a very small volume. Okay, then the last part I want to minus off, right, after minusing off the so-called the blue region, you'll notice there's a straight line. Now, straight line normally will give us a regular figure, meaning maybe a cylinder, a cone, etc., etc. So you can see that there's a cone here. So you can see here. So as what you have annotated here is 5. So the radius, right, because when you do the revolution, you will get something like a cone. So let me just draw something like that. So this is a cone. So the cone has a radius of so-called 5. Because from here to here, right, from here all the way to here has a 5 units. And there's a so-called height of the cone. So the height of the cone will be from here all the way to here. So this is also 5 units because at this point, -3, at this point is +2. So from -3 to +2 is about 5 units. So this is 5 units. So you just, of course, can I use the integration? Definitely yes, but never, we just use the 1/3 pi r square height. So this will be, the third thing that I want to minus off, right, will be volume of cone. So this is 1/3 pi r square. So r square is about 5 square, then you times height. So this will give you roughly something to be 130, I think. Okay, so 1/3 pi r square times height. Okay, so it's about 130. 130.8996939. Okay, then with this, I can minus off already. So you just simply use this, minus off this, minus off this, right? So this will give you a resulting volume, right? The volume of region, I think it's R, right? Okay, sorry, region S. The volume of S is about 327. So 327.25. Yeah, because they want 2 dp. So just put the volume of S, right, will be 327.25 unit cube. Yep, so that's all. So for this one, the first one you put in the GC, the second one you also put in the GC. Then for the volume of cone, you simply just use the regular mensuration formula. That will give you the answer already.